Welcome everyone. In this video, we're going to learn how to graph cubic functions if the factored form is given. So we already learned in a previous video how to graph a cubic function if the general form is given. So what's the difference in here? In general form, we need to factorize the function first and then graph it. But in here, the factored form is given already. So it's much simpler compared to the general form. Let's get on to an example. So y equals x minus 2 the whole square times x plus 1. So this is the function we go into plot. So what are the steps involved in here? So the first thing we need to do is to find the y-intercept. So that's what we're going to do first, the y-intercept. So what is y-intercept? The y-intercept is the value of the function at which it crosses the y-axis or when x equals 0. Okay, and finding that is quite easy. Substitute x equals 0 into this equation, which we can do quite easily. So x equals 0, it gives the first term as minus 2 square, and x equals 0 again, so it's a 1, so which is 4. So y equals 4 is the y-intercepts, or the coordinates are 0, 4. We got the y-intercept now, and what is next? We're going to find the x-intercept. So what is the x-intercept? These are the points where it crosses the x-axis. Okay, so that's obtained when we substitute y equals 0 into this equation. Let's put that in here. Y equals 0 gives x minus 2 the whole square times x plus 1. And now you know how to find the x values, which is by applying the null factor law. If I times b is 0, a equals 0, and b equals 0 are the two chances. Okay, let's take the first one, x minus 2 the whole square equals 0. That's simply, so this is equals 0 if x minus 2 equals 0. So let's do that. And this equals 0 be only if x equals 2. But because this is a square term, we get two solutions, x equals 2. X equals 2 is a repeated solution. Okay, so what does it mean? So if it's a repeated solution, that's actually is a turning point. So this gives us a turning point as well. So one of the x-intercept is 2, 0. So what's the other x-intercept? So we get x, the other intercept when you equate this to 0, so which is x plus 1 equals 0, or x equals minus 1. So the other x-intercept is minus 1, 0. And as I said, this is actually a turning point as well because this factor is repeated twice. So let's now put all these points into this graph. The first one is 0, 4. It's y-intercept. So that's this point. So that's 0. Okay, 0, 4. Let's put that one in here. And the other points are x-intercepts. That's 2, 0. This is already a turning point as well because the factor is repeated twice. And that's 2, 0. And the other point on the graph is minus 1, 0. So that's this one, minus 1, 0. Okay, so now the graph roughly looks like it will be going like this and then crossing this point and then going like that. Oh, this is a turning point, so it will be going something like that. But to graph a function of degree 3, or in general a function of degree n, we need at least n plus 1 distinct points. So in this one, we need at least 4 points. Yeah, so we already got 3 points and we need one more point. And which point you will look for? I think we should aim for that next turning point because we know this graph is going turning in here, and we don't know exactly if the turning point is on this side or on the other side and how high it can go. So sometimes you might be thinking, okay, I know the two closest, the nearest x-intercept, and the turning point is exactly at the middle. No, that's for the quadratic functions. In cubic functions, that's not exactly at the middle. So we need to find the turning point. So what is the best way to find the turning point? The turning point is a stationary point. At stationary point, the first derivative of the function goes to 0. So we can find the first derivative of this function using calculus and find the turning point. But some of you might haven't learned the differentiation. So if that's the case, you can estimate the graph for now. And then when you learn the differentiation, you can come back and do this part. Okay, let me find the first derivative of this function. So dy on dx, it's a y dash. I'm going to write it as y dash. And we need to apply the product rule. The first times the derivative of the second plus the second times the derivative of the first. Okay, so x minus 2 the whole square is the first term. Derivative of the second is 1. And then plus the second term, x plus 1. And the derivative of the first, which is 2 times x minus 2. Okay, so this can be equated to 0 because we're trying to find the turning point or the stationary point. Okay, so we can do a little bit of simplification here. So we can take x minus 2 as a common factor. So x minus 2 times x minus 2 should be inside because 2x minus 2 in here in the first term, and plus 2 times x plus 1, and that equals 0. Okay, now let's do a little bit more simplification inside the within the brackets. That's x minus 2 times x minus 2 plus x minus 2 plus expand this bracket, which is 2x plus 2 equals 0. So which is x minus 2 times x 2x plus x. The similar terms can be combined, so it's a 3x equals 0. So we need to apply the null factor again. Okay, the first one, x minus 2 equals 0, which is not a surprising result because that gives x equals 2 is the turning point, which we already knew because this factor was repeated twice. The other one is saying 3x equals 0, and that's possible only if x equals 0. And so this is again a cool result for this one because it says the point which we already had is a turning point itself. Okay, so this is a turning point, and now we can draw. If you want, you can find one more extra point by just substituting x equals minus 2 or minus 3 or x equals 4. It's up to you, but this is enough to plot this graph. So what we're going to do is join all these points together into a nice and neat graph. What if you didn't know differentiation and you wanted to do a decent sketch in here? So what you can do is you can take 2 points next to this y-intercept, maybe x equals 0.5 and x equals minus 0.5, so that's just opposite to the y-intercept, and you can find the corresponding y values as well by substituting that into this equation. So that will give you 2 points on either side of the y-intercept and give you an indication of whether the turning point is right or turning point is left or is approximately on the y-intercept itself. Okay, so this is how you draw the graph of a cubic function. If the factored form is given, find the y-intercept, find the x-intercept, and find the turning points and any extra points if that's required.